Yesterday, we started working with fractions on a number line. We partitioned a number line into different fractional parts and labeled the unit fractions. Today, we're going to continue that work as we look at a number line and figure out how to place or identify any fraction on a number line. Let's take a look at the problem of the day. How did you represent and solve this problem? Share your answer out loud. I heard you say that first you labeled 0 holes and 1 hole to show 1 hole on our number line. That's smart. It's always helpful to label your holes so that you can clearly see the distance from 0 to 1 hole. How do you partition your hole and why? Say your answer out loud. I heard you say that you partitioned the number line into 6 parts because the denominator of Ladisi's fraction, 4/6, tells us how many parts our whole is broken up into. In this problem, the denominator is 6, so we need 6 parts. What is the best way to partition our number line into 6? Say your answer out loud. I heard you say that we should cut our number line or partition our number line into thirds first. And then partition those thirds into halves, just like when we made 6 out of different shapes. Smart. Why was that helpful? That's right. That's helpful because it helps us make sure that our parts are the same size. I always like to count my intervals to make sure that I have the right number of parts. 1, 2, 3, 4, 5, 6. Great. We have the right number of parts. What is the unit fraction here and how do you know? Say your answer out loud. That's right. I heard you say the unit fraction is 1/6. The unit fraction is 1/6 because we know that we're referring to just one part out of the total number of parts in one whole, which was 6. Great mathematicians can always identify fractions on a number line by thinking, what is the unit fraction first? How did you figure out where 4/6 was on the number line? I heard you say you started at 0 and counted the intervals or the spaces like this. 1/6, 2/6, 3/6, 4/6. Why did you stop at 4/6? That's right, we stopped at 4/6 because we know that the numerator tells us how many parts are being referred to. So 4 intervals means 4/6. Team, I've got a tricky question for you. Why is it 4/6 and not just 4? Why didn't we count 1, 2, 3, 4? Say your answer out loud. You're exactly right. I heard you say that we didn't count 1 hole, 2 hole, 3 hole, 4 holes because each interval is not 1 hole. Each interval is 1/6. The unit fraction is the building block here because we know that each interval is just a copy of 1/6. Smart. When we're placing fractions on a number line, we want to think, what is our unit fraction? And then we can count our intervals from endpoint to endpoint by the unit fraction, just like we did here. How can we label the rest of this number line with sixths? Share your answers out loud. That's right. We can count by the unit fraction and label as we go. Let's do that together. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. Team, why do we have 6/6 here? I thought it said 1 whole. Why do we have 6/6 here? Share your answer out loud. That's right. We have 6/6 here because anytime a fraction is referring to all of its parts, that means the denominator and the numerator are the same, it is equal to 1 whole. How many sixths are here, and how do you know? Say your answer out loud. That's right. There's 0/6 here because there's 0 parts being referred to. We can represent this in fraction notation by writing 0/6. Team, as you jump into your try one more, remember, we can identify fractions on a number line by thinking, what is the unit fraction, which is 1 part out of all the parts in 1 whole? And then we can count our intervals from endpoint to endpoint by counting by the unit fraction, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. Keep that in mind as you move on to the next problem.